Alright, Algebra half. In this video we're going to be going over the test review for lessons 77 through 90. We're going to start on this first page with how to graph a line. Now you notice we want to make sure we understand this is the equation of a line. We'll talk more about the structure of it in a future math class, but for us, all we need to remember is that this is a rule that relates the variables x and y through a specific relationship or set of operations. For example, in this first one, it simply says whatever x is, if you take 2 away from it, you can get the y. So again, I want you to remember that you can consider this the input and y would therefore be the output. Kind of like that. You'll go on again to represent this in a few different ways, but for now, for our purposes, this is what's going to be best. Secondly, the way we have talked about getting from the equation to the graph is through making a table. In your book, they usually give you x values to plug into your table inputs, and you plug those in and evaluate that particular part of the expression to produce an output, a number for y. But I'm not going to give you those values. I simply want you to choose any 3, and I want one of them to be 0. Okay? I will always want you to do 0, and that'll make more sense next year as well. But it's always one of the numbers I want you to do because it's an important point on our graphs, which we'll talk about also in a future class. But nonetheless, you can use any negative number that's seen over here. Again, if I choose an x value, again, that's some number on this axis. So let's say I choose -2, and then somewhere in the positive. So let's choose +3. Okay, so these are my 3 x values. What I'm going to do is substitute them in for x. So, again, what I would do here, when I'm plugging in -2 for x, that would be -2 minus 2. Again, this is like the x, subtract 2. That's going to give me -4. Well, what does that mean? Again, this is an xy table, but it's a relationship between the x and y. When x is -2, y is -4. That represents a solution to this equation, and therefore it represents a point on the graph. So I'm going to plot it. -2 on the x means I'm going to go left 2. -4 on the y means we're going to go down 4 from there. So this would be the point that we're looking at. Let's plug in 0. So that would be 0 minus 2. 0 minus 2. That's -2. So I have an x value of 0, a y value of -2. But the x value of 0 is here. And then we'll go down to for that y value. Okay, last one, 3. When x is 3, so I'll plug in 3. 3 minus 2 is 1. Right, 3 up 1. And again, you'll know you've done this correctly if you connect these in a straight line. Again, all lines are straight, but I felt like I needed to speak that redundantly for us because we haven't quite gotten to the reason yet. All lines are straight because they travel at a constant rate, is the rhyme I like to make. Okay, so this represents the line, or this is the line that represents this particular linear equation. Again, we connect the dots because in reality, any dot we choose on this line would be a solution to this equation. This is a picture of this mathematical collection of symbols. Okay, so number 2, let's do the same thing. Let's choose 3 x values, one of them 0, plug them in, and see what the corresponding or matching y values are. So let's plug in -1, and let's go on to let's do 2. Okay. And I chose those to make sure they'll show up. You'll have a little bit more freedom on your test. But to plug in -1, again, what does that look like? Y equals -3 times. I'm going to replace or substitute x with this x value, this input of -1 plus 1. So this is going to produce one solution. -3 times -1 is +3 plus 1 is 4. So the matching y value is 4. -1, 4 is right there. Let's plug in 0. 0 is really easy to do because anything times 0 is still 0. So -3 times 0 is 0 plus 1. That's 1 for the y value. So 0, 1, 0, 1. And then 2. Okay, so again, what does that look like? I've got a little room down here. Y equals negative 3. I'm replacing it with a positive 2. X is 2. Again, we're going to treat it, what if X is 2, so to speak. Negative 6 plus 1, that's a negative 5. So negative 5 is the matching Y value. This becomes a coordinate pair, calls a pair because they're matched based on how they satisfy this relationship. 2, negative 5. 1, 2, 3, 4, 5. That's down here. Okay. Now again, you'll know you're correct if it makes a perfectly straight line. And we'll learn more about how do we tell if the line is straight later. Quick preview, you can kind of look at the triangles that are made here and understand you're going to have a straight line because you're going to talk about the rate of change between the points eventually. But these last two, pause the video and give these a try. Just to give you a hint though, I am going to tell you to use the values negative 4 and positive 6. Okay, actually let's do positive 2. We can't fit 6 on there because we don't have enough space, so positive 2. Okay, like I said, pause the video, give these a try. Alright, when we plug in negative 4, right, so let's show what that looks like. Y equals 1/2 times negative 4 minus 4. Well, 1/2 of negative 4, that's going to be negative 2 minus 4. That's negative 6. Negative 4, negative 6. So that'd be way down here. All right, 1, 2, 3, 4, 5, 6. I went left 4, down 6. 0. Well, half of 0 is still 0 minus 4. That's negative 4. 0, negative 4. And then one more. We're going to plug in 2, right? So again, y equals 1/2 of the value 2 minus 4. So again, all of these are like, what if x is 2? Get an answer. Y would be blank. What if x is negative 4? Y would be, we said, negative 6. But again, what if x is 2? Half of 2 is 1. 1 minus 4 is negative 3. So that is the matching value. Right 2, down 3. And check it out. It does make a perfectly straight line. Again, all lines by definition are straight. Otherwise, we'd call it a curve. But you get what I'm saying. All right, this one will be really quick and easy. We'll do negative 1 and positive 1. So when I plug in negative 1, 5 times negative 1 is negative 5. 5 times 0 is 0. 5 times positive 1 is positive 5. Let's plot these 3 points. Negative 1, negative 5. 0, 0. Positive 1, positive 5. And there it is. Right? So again, let's make sure we see. All we have to do is make a table, choose some x values, substitute them in as inputs, and find the corresponding y values, which are the outputs. So if we go back up here to this particular example, let's say negative 1, 4 came from me substituting negative 1 in for x and evaluating, finding out what does that equal, or solving it. And then from there we could plot it as a point right there. Likewise, again, this particular relationship or pair came from substituting in 2 for x, getting 5 as an output, negative 4, and plotting that point. The next section is all about percents. So the way the book describes this, the percent of a number is another number. Sounds kind of vague, but let's remember a few things. The percent means the quantity out of 100, or p over 100. So per 100. So 89% becomes 89 out of 100, which is where we get this rule that 89% as a number is 0.89. 100% becomes 1 in an equation. You could say it's 1.00 because 100% means 100 per 100. And that's why we get 1. 250%, right? I talked about a lesson where percents over 100 were a thing. 250% becomes 2.5. Again, you can simply check it. 250 divided by 100 is 2.5. The percent sign, again, is simply a rule that says, hey, take this portion out of 100. So when we add a percentage of a number, that implies that 100% of the number was there to begin with. What in the world do I mean there? Well, 24% more than 10 means I'm going to start with 10, and then I'm going to add 24% of 10. Okay? What we are going to gather is that that's the same thing as saying 10 times 1.24. The 1 is the 10 that was already there. Okay. 10 times 1 is 10. And then the 0.24 is the part that we're increasing by. Okay. So just something to keep in mind there. Everybody kind of has something, their own way of doing these. So start simple. What percent is 51 of 51 is 17? So if you think about that, percent of a number is another number. What percent? So I'm looking for P of 51 is 17. So P of 51 is 17. All we got to do there is divide by 51 on both sides. And we're going to get 0.3 repeating. So we can say 33.3%. Otherwise known as 1/3. 45% of 200. So again, the same equation is going to help us there. 45, so 0.45 is how we represent 45%, right? 0.45 of 200. So we're going to multiply times 200 is, well, there's the is, equals. Well, that's just something we type in our calculator. We're going to get 90. Number 7. Go ahead and try this one. What is 170% of 20? Well, technically, I guess you've already tried them if you did these like you were supposed to yesterday. What is 170% of 20? So what is, so we can say B is 170%. We know that's 1.7 of and then 20. Okay, so we're going to get 30 something, right? 34? Is that right? I should probably check that. No, I'm right. It's 34. Okay, so again, 170% turned into 1.7. Again, that's like saying 100% of 20 plus 70% of 20. And so hopefully you guys are aware that 100% of 20 is 20. 70% of 20 is 14. 20 plus 14 gives us 34. Okay, now 75 is what percent of 25? 75 is, there's my equal sign, what percent? So P of 25. All right, so again, I'm looking for the percentage. How do I solve for P if it's being multiplied by 25? I'm going to divide by 25 on both sides. And here's the weird thing. You're going to get 3 equals P. But 3 is a number, not a percent in this particular problem. Going back up to the rules up here, 2.5 in an equation was 250%. So 3 in an equation is 300%. You can think of this more simply as 3 times the original, right? 3 times the original. Well, that's 300%. Okay, what is the percent increase from 25 to 75? So again, if I'm looking for the increase, I'm looking for what percent did we add to 25 to get to 75. Okay, we talked about the formula yesterday in class. New minus original over original. Always going to divide by the original. So the new is 75, the original is 25, and we're going to divide by 25. That's going to give us 50 over 25, or 2. 2 represents a 200% increase. Now, what's the difference in these two problems? Here, I'm saying 75 is 300% of 25. Here, we're saying we're going to add 200% to 25 to get 75. So the difference. Okay, algebraic phrases. So again, keep in mind some of these operator words: 3 less than, twice a number, product, increase by, decrease by, quotient, product. You guys are pretty good with those. 3 less than, though, implies that you're going to have to start with something else. And then you're going to take 3 away from it. Oops, 3 less than. Let me fix that. 2n minus 3 is 31. Okay. 2n minus 3 is 31. We're going to be able to solve that. This is a 2-step equation. Make sure you realize that, hey, all this easy part, the is, kind of tells you where the equal sign is. 2 steps. Deal with the constant first. We're going to add or subtract. We're going to add it because that's going to cancel it to move it over here effectively. And I've got 2n equals 34. because the 2 is multiplying the n, and I want to know what n by itself is, I'm going to have to divide that 2 away. Do it to both sides. We're going to get n is 17. Number 11, the product of a number and 4. Product means multiply, a number and 4. So you can say n times 4. It's going to be much quicker and simpler to say 4n. Increased by 12. Uh-oh, I skipped too soon. Increased by 12. Increase, we're going to add. And then is 52. There's that is 52. Is our equal sign. So if we have 4n plus 12 equals 52, we're going to move the constant over first. We're going to add or subtract. We're going to subtract because that's what causes it to cancel out. Reduces the amount of stuff going on over here. And that's 40. Then I see that I'm multiplying here, so 4 is going to be divided on both sides. We'll get n equals 10. Last one. 23 decreased by a number is 31. 23 decreased by, so decreased by some number, is 31. There's my equal sign. Output. Okay, how do we do this one? Well, we're going to deal with the constant first, just like we always have. But that n is being subtracted, so that's going to be, we're going to have to keep that in mind. The 23 is positive, so I need to subtract it from both sides. I've got negative n, or minus n, equals 8. Oh, what now? Well, that negative is like a negative 1 times n, so I can actually just divide both sides by negative 1, and I'll get n is equal to negative 8. Now that makes sense, because if you say 23 minus a number and it gets bigger, you must have been subtracting a negative, so that when the two negatives combine, it ends up adding the value. And the last page, ratios and proportions. So you can use a proportion to solve any ratio problem. Fred won 17 awards in 3 years. Okay, I'm going to abbreviate here for time's sake. How long will it take him to win 51 awards at this rate? So what we're going to say is equals 51 awards. Okay, so you notice I did awards over years. I'm going to have to do 51 awards over X years. T years, whatever letter you want to use. The key here is that I did awards over years. I have to do that on both sides. That's it. That's all you do to write the proportion. And then to solve it, we're going to cross multiply. So I have 17x equals 51 times 3, or 153. And so when we divide by 17, because we're multiplying, we're going to get x equals 9. Yes, that's all. A barbell started to chip as we dropped it onto the floor repeatedly. I weighed the first piece that chipped off, and it was 2.7 pounds. If this represented 2/21 of the whole, how much did the original plate weigh? Well, this might seem like a much more complicated problem, but it's actually still a ratio and proportion problem. What I can do, I can say 2.7 pounds out of W for the whole is equal to this ratio, 2/21. And I'm going to do the same thing. I'm going to cross multiply. 2W equals, let's see, what would that be? 2.7 times 21. We're going to get 56.7. And so we'll divide by 2. And we'll get W equals 28.35 pounds. So the entire thing must have been 28.35 pounds. Again, all I did was use 2.7 out of the whole set equal to the ratio that was given. Once you set one ratio equal to another ratio, we call that a proportion, and you can cross multiply. For surface area, find the surface area of a half cylinder with a diameter of 12 millimeters. Let's go ahead and say, okay, that means the radius is 6 millimeters and a height of 20 millimeters. Surface area of a half cylinder. Okay, so what is a half cylinder exactly? It's got a rectangle over here, and then we've got that curved side that's going to come on down like that. We've got this curve on the back. The radius is 6, so that means the diameter is 12. So we already know that's 12. The height is 20. Find the surface area. So the surface area, again, is all the different surfaces. I'm going to go ahead and draw this out here. This is a 6 millimeter radius. So what surfaces are present? Well, we have a top and a bottom. So one semicircle plus another semicircle, that would be a whole circle. And so the area of the whole circle is just pi r squared. So the area of the circles, we're going to have pi times 6 squared. So that's going to be 36 pi. going to be the pink part. Okay, and I'll run out of colors and the ability for colors to show through, so I'm not going to do a whole lot more. Then we've got this nice little rectangle here, which is pretty straightforward. The area of the rectangle, 20 times 12, base times height, or length times width, right? So 240 millimeters squared. That was millimeters squared. Okay, and lastly, we have this sheet that kind of goes around. It goes all the way around. So what we want to make sure we understand is that this yellow part, if extended, well, it's going to have a height of 20 millimeters, but it's going to have a length that is equal to half the circumference. So the half the circumference, we can say that's C over 2. If this is a circumference formula, we could just divide the 2 out. So that would be equal to pi r, or 6 pi. Really? That's all? Yes. That's it. 20 times 6 pi, that's 120 pi. So the area of the, we'll call it the sheet, I don't have any other word for it, is 120 pi millimeters squared. Now what could we do to figure this out, what this decimal was? We're just going to type it in our calculator. We're just going to add these values up. Okay? So let's see. We've got 240, well, let's say 36 pi plus 120 pi. That would be 156 pi for anybody really wanted to know. And then plus 240, 730. We're just going to round. We're going to say 730 millimeters squared. Okay, so again, the important thing to remember there is this curved sheet can just be turned into a rectangle if you simply calculate what the dimensions are. And the dimensions, again, the height is given to you there. The length, right, how much would that roll out to be in a straight line, is just that curved distance, which we identify as the circumference. In this particular case, it's half the circumference because it's a half cylinder. Now, what mistake did I make? I spotted already. There were 2 circles. Oh, I didn't make a mistake because I did the entire area. Okay, we're good. Last one. A semicircular section, half cylinder, is attached at both ends of a rectangular box. Okay, so let's draw this. Semicircular section. Both ends of a rectangular box. The radius of the semicircle is 12 feet. So that means this is the diameter. That's going to be 24. The box is 18 feet long and 6 feet tall. Oh, okay. And then the straight line looks kind of like one of those bathtubs people like. So I'm going to just do like a little dotted line here because they're technically touching there. 6 feet tall, so that's 6. And then the box is 18 feet long. So this is clearly not to scale. But this is what we have. Find the total surface area. So, in order to figure this out, we're going to have to do it in stages. I would advise you to simply break it up into 3 sections. 1, 2, 3. But, here's a great benefit. 1 and 3 will combine to make a whole cylinder. So we can treat this like a whole cylinder because you can see all of those sides, and then a rectangular prism, but not including those flat faces where the half cylinders attach. Okay? Not including these flat faces here. Again, those will close up and you'll get just a cylinder that was cut in half to be attached to those, right? Okay, so let's do this. We're going to do 1 and 3 together. And you may remember the formula for the surface area. Surface area of the cylinder is, what is it? Well, there's 2 circles. So pi r squared times 2, there's a top and a bottom, plus, and then the outer rim, again, that's just going to, if you unravel that or uncurve it into a straight line, that's the circumference, so that's 2 pi r, or the length, times the height, or the width, which is the height of the actual cylinder. In this case, the measurement is 6. Okay, so Let me simplify that a little bit. The surface area of the cylinder. The radius we said was 12. So I have pi times 12 squared, times 2 plus 2 pi times 12 times 6. So I'm going to just use that formula there. So let's see, 144. So we've got 288 pi here plus 2 times 6 times 12, 144 pi. Or 400, let's see, what is that? 32 pi feet squared. Oh, well, that's just a cylinder. What's left? Well, what's left is actually the easy part. I have a top and a bottom that are identical. So the surface area of the rectangle, again, we're not including these faces where the cylinders are attached. So I really only got 4 sides to find, 2 pairs of them. So that equals, sorry, not plus, equals. So for this top side, you look, that's 18 by 24. I have 18 by 24, and I have a top and a bottom that are identical, so we'll just multiply that by 2. Plus, now I have these sides, which are 18 by 6, and I have 2 of them on the right and the left. So 18 times 6, and there are 2 of them. See, much easier than the circle. Maybe much faster, not much easier. So, what we can do, 18 times 24 times 2 plus 18 times 6 times 2. I'm going to go to my calculator so that I don't screw something up in the middle of a video. Times 2 equals 864. So there's 864. And then we have 18 times 12, or 216. Added together, we're going to get 1,080 feet squared. So obviously, if we're finding the total surface area, we would add 1080 to 432 pi. So I'll do that really quick. Plus 432 pi. And we're going to get 2437.17 feet squared. That's a lot of surface area. That must be a big box. Alright, so again, break these problems down into steps, especially when there's a drawing. If you don't understand something about the drawing, you can just ask a question on the test. But again, practice is going to help you here. So hopefully this clears up any issues you guys are having. Good luck studying, and I'll see you Thursday.